Section 9.4 deals with composition of isometries. So the first thing we have to look at is just the notation that we use. This looks similar to function notation when we're doing composition of functions in algebra. So we're talking about composition of this reflection and this reflection for segment AB. The way we understand this is we work from inside out. So first we're going to do the reflection of segment AB across line L. We're going to get A prime, B prime as our image when we do that. And then we're going to reflect that new segment A prime, B prime across line M second. So first reflect across line L, second reflect across line M. So let's look at an example here. And we'll just do this in non-coordinate format. I have two parallel lines, lines L and M. And here's my segment AB. So, as we've talked about with reflections, we find the distance from a point to its line of reflection. So A is this far away on this side, so it's going to be the same distance away on the other side. And I'm not measuring this, I draw it freehand. But it just gives us an idea. So there's A prime. And B will be this far away from L. So it will be this B prime will be the same distance away. Right about there. And so there's A prime, B prime reflected across line L from AB. Now if we're going to reflect this across line M, once again, find the distance from A prime now. And so there's A double prime, and find the distance from B prime to line M. And so A prime, double prime, B double prime will be our resulting segment. Now, this resulting segment, I'll draw in red, just to highlight it. When we reflect across two parallel lines, essentially we're just doing a translation from AB to A double prime, B double prime. Just sliding that across and see how it maintains distance between the 2 points. That's why it's an isometry. If we're going to do a composition across two intersecting lines, so using the same notation, reflect across line L, then line M. So A is this far away from the perpendicular line. A is that far away from line L. So A prime will be right there. And B is this far away from line L. So B went a little long there. B prime will be right about there. Now, to reflect across line M, it's going to be a little tricky here. So let's ignore line M, and we're going to use our ruler to create a perpendicular line here. So there's a line that's perpendicular to M through A, and so that's the distance from A to M. And so if we hold our straight edge at that angle and just extend it now along that line, maybe about that far on the other side. Again, ignore line L. Now let's try B prime. So that's where it's perpendicular to line M. And that's how far it's going to be. And so, right about there. So I'm going to connect A double prime and B double prime. And if we look at R2, let me highlight our initial, our pre-image, our initial segment, our pre-image. And our image. This is the same as a rotation. So we've taken A, segment AB, and we've rotated it all the way over to A double prime, B double prime. Now the last piece in this is working in a coordinate plane. And so if we are asked to do a composition of reflection and a translation, of segment MN, here's what it's going to look like. Let's take M as 1/6 and N as 5/4. So M 1,6 and N at 5,4. Okay, so first, as we talked about earlier, first we're going to translate each point, -1, -3. So we're going to move M left 1 and down 3. And we're going to move N left 1 and down 3. So there's M prime, N prime. Now let's take this segment and we're going to reflect it across the line x equals 2. So we draw that line, x equals 2. Remember, every single x value on that line is 2. So that's why it's a horizontal line. And now we're going to find the distance. So M prime is 2 units away. So M double prime will be right there. N prime is 2 units away. So N double prime will be 2 units away. And so our final answer will be this segment right here, where M double prime has the coordinates 4, 3, and N double prime has the coordinates 0, 1.